Okay, so we've talked about sine theta and how it represents the opposite, or it allows for the correct relationship between the opposite, the hypotenuse, and the adjacent of a right angle triangle. So O, we are stating, is this line here. It's exactly the same color of the line. So let's just change that somewhat. So O is representing this line here. It's a little bit of a recap. Hypotenuse is representing slightly different circumstance. It is representing this largest side. There is our theta, and sine theta will give you the relationship between these two. So for example, we're aware that when we were looking at for such things as sine at 30 degrees, the opposite would be half the size as the hypotenuse, or the hypotenuse is twice as big as the opposite. So for example, if I therefore was to make this 100 and this 50, the angle would be 30 degrees to produce a normal right angle triangle. Now, in these circumstances as well, just to recall, we also have the adjacent side, but the adjacent side is represented more so, or allows for, we can have a discussion about it more so with regards to the cos function. Today what we're going to look at, however, is mainly about figuring out the angle, having been given the sides and their values. So in the past we've decided what the angles are, and we've figured out what values come out for sine theta and cos theta in terms of the relationship between adjacent and hypotenuse, and for sine theta between opposite and hypotenuse, like so. What about if you wish to find the angle? So what I've suggested here, what I've said is, let's also remember that if you're going to do exam questions, be aware that you can have x representing this angle. So this here could instead be x, and that is coming out in some of the questions I am getting with regards to some of the problems we have. Sine x is the same thing. It represents the opposite over hypotenuse for right angle triangle. And what I want you to do is just be aware, we've already made this clear, that h is the length of the hypotenuse and O is the opposite of that right angle triangle, opposite of this angle here. Okay, so given that we know what the opposite and hypotenuse sides are, for example 10 centimeters opposite side and 20 centimeters hypotenuse side, it is possible to work out the angle. We can do that with geometry. We can sit down and draw it perfectly and then actually find out by way of utilizing instruments to figure out exactly what that angle is. But we don't need to do that. Let's say you want to use a calculator, you don't want to play around with such things as protractors. So what we're going to do instead is we're going to look at working out with our calculator and what that looks like. What we do is we represent this as writing when we want to figure out the angle. So let's say in these circumstances my angle is not known, theta. We write sine to the power minus 1, sine minus 1 on our calculators using the shift button. We use shift sine on our calculators, and what we will do is then type in the values that we're given in the question. So for example, let's say that the values we're given in the question were at 20 centimeters and 10 centimeters. So let's say that this triangle here, this length is 10 centimeters and this one is 20 centimeters. We do not need the units, so therefore, because we're looking at this ratio 1 relative to 2, which we have seen before with sine, when we have a situation of the hypotenuse being 2 and the opposite being 1, so 1 relative to 2, we know that the angle should be 30 degrees for that, in order to produce that type of right angle triangle. So if I type into my calculator sine to the power minus 1, 10 over 20, I will get that angle 30 degrees. And I would suggest you have a go typing it. You can have 1 over 2, 10 over 20. Remember they're ratios, so it doesn't really matter as long as it's the correct numbering within there. And that is how you can use your calculator to obtain the angle given the size relative to the circumstances where instead, if you were to use this equation, you would type in the angle, say for example sine 30, and you'd end up with the ratio, or the value of opposite divided by hypotenuse coming out of there. And I suggest you have a go at playing with those two things using calculator, sine and shift sine to see what comes out.